Hey everyone, so every single time you send an email, stream a movie, or just scroll through your feed, you're using one of the most incredible things humanity has ever built. But what is it, really? We're about to go on the real physical journey your data takes, from your screen to the other side of the world and back, all in literally the blink of an eye.
So let's just start with a basic question. When I say the internet, what do you actually picture in your head? Is it a cloud? Is it just the apps on your phone? The truth is, the internet is something you can actually see and touch, and its physical reality is honestly way more fascinating than you probably think.
You know, you can really look at the internet in two totally different ways. First, there's what we could call the services view. That's all the stuff we use, right? The websites, the streaming, the games. But underneath all that is the physical view, the actual hardware, billions of devices, routers, and this massive network of cables and radio waves that connect everything. And that is the journey we're taking today.
Now, all this communication, it isn't chaos. It's all governed by rules, and we call these rules protocols. The easiest way to think about it is just like a human conversation. You say hi, I say hi back. You ask for the time, I tell you the time. Well, network protocols are pretty much the same thing, just a very structured conversation between computers to ask for and receive stuff, like a web page. This simple back and forth happens billions of times, every single second, all across the globe.
So where does this whole incredible journey begin? Well, it starts with you, right at what we call the network's edge.
So, this network edge, it's basically where the internet begins and ends for any given task. It's made up of things called hosts. On one side, you've got clients. That's your phone, your laptop, your game console. And on the other, you've got servers, which are the powerful computers that hold all the websites and data, often living in these absolutely massive data centers.
Okay, so you've got your device, the clients, and it needs to talk to a server somewhere out there. How does it get onto what people used to call the information superhighway? Well, it gets on through something called an access network. Just think of it like the on-ramp to the freeway. Which, of course, leads us to a really crucial question. How do our devices actually connect to that very first router, that gateway to the rest of the internet, to even begin their journey? For most of us, it happens in one of three main ways. You've got your residential networks, at home. You've got institutional networks at work or school. And of course, the mobile networks we use pretty much everywhere else. Let's take a quick look at the most common ones.
All right, first up is the on-ramp that so many of us use at home, good old cable internet.
Cable internet uses the exact same lines, a mix of fiber optic and coaxial cable that deliver your TV signal. Now, the key thing to know about cable is that it's a shared connection. All the houses on your block are basically sharing the same line back to a central point. And that shared setup is why your connection is asymmetric, which just means your download speed is way, way faster than your upload speed.
Now, the other classic home on-ramp is DSL. That stands for Digital Subscriber Line.
DSL is pretty clever. It actually uses the existing copper telephone lines that are already running into your house. Now, the big difference from cable is that you get a dedicated line. You're not sharing it with your neighbors. The trade-off, though, is that the speeds are generally a lot lower than what you can get from a modern cable connection.
So let's just break it down real quick. The main difference is right there in the connection type. Cable gives you potentially higher speeds, but you're sharing the road with your neighbors over a TV line. DSL gives you your own private lane, but it's usually a slower one, all happening over a phone line. Two very different on-ramps built on top of two very different older networks. But, let's be real. Today, a lot of our on-ramps don't even involve plugging a physical cable into the wall, right? So let's talk about wireless. We mostly connect without wires in two main ways. Inside, we use a wireless local area network, which everyone on Earth just calls Wi-Fi, that covers, 100 feet or so. And when we're out and about, we jump onto wide area cellular networks like 4G and 5G, which can cover distances for miles. Okay, so once our data is on the on-ramp, what are the actual roads it travels on? This brings us to the physical media, the real-deal wires and waves that carry all our information. So the physical paths your data takes, they really fall into two big categories. First, you have guided media, where the signal is contained inside a solid path, like a copper wire or a fiber optic cable. Then you have unguided media, where the signal just propagates freely through the air. Think radio waves. The main guided roads are probably pretty familiar to you. You've got twisted pair copper wires inside Ethernet cables and that coaxial cable for your TV and internet. But the true superstar, the absolute backbone of the modern internet, is fiber optic cable. It's not sending electricity, it's sending light. and it forms the high-speed core of our entire connected world.
So why is fiber king?
Well, instead of pushing electricity down a wire, it shoots pulses of light down a strand of glass that's thinner than a human hair. This lets it achieve almost unbelievable speeds. We're talking hundreds of gigabits per second on just one fiber. And because it's light, it's not affected by electromagnetic noise, which makes it incredibly reliable.
Okay, so what about the unguided roads? Well, when there isn't a physical wire, our data is literally flying through the air as radio waves. And as you can see, these wireless technologies are built for totally different scales. Bluetooth is for really short distances. It's basically just a cable replacement. Wi-Fi can cover a room, maybe a whole building, and then cellular networks like 4G and 5G connect us over miles and miles. All right, let's zoom all the way out now and put all these pieces together. The edge, the on-ramps, the physical roads, to finally see the big picture.
When you put it all together, you get this. And this is the most important idea to take away. The internet is a network of networks. It isn't owned or controlled by any single company or any one government. It's a massive, decentralized, global team sport. It's thousands and thousands of independent networks run by your local internet service provider, giant tech companies, universities, you name it, that have all agreed to speak the same language, the same protocols to seamlessly pass our data along to each other. It's an absolute miracle of cooperative engineering.
See, the internet isn't some magical, fluffy cloud. It's a real physical wonder, a planet-spanning machine made of glass fibers under the ocean, copper wires in our walls, and radio waves flying through the air. Now that you know the actual path your data takes, what part of this incredible journey will you see differently the next time you go online?